And to continue our discussion of factoring methods, we're going to look at special forms. And so this one is more, I don't like to say memorization, but it takes a little bit more work with pattern analysis to see these. But if you have this first one, a squared minus b squared, that general factor says a minus b, a plus b, so different signs. And going from left or from right to left, like that pattern is clear, but then going from left to right, that isn't always so clear. So that's why it might take a little bit to recognize this. This is called a difference of squares. Difference, I'm going to abbreviate, of squares. Okay, so this one, I'm going to tell you, I love to quiz you on this one, so make sure to get practice with this one. And then these second ones, these are so instead of having different signs, you have the same sign, so either addition in both places or subtraction in both places between two factors, or two binomials, I should say. And so then the only thing that changes between them really is that sign of the mixed term. That's all that changes between them. So plus, it's plus, minus, it's minus. That's all it really is. These are called perfect squares. Okay, so now we want to get some practice with these. So that's the general idea. Now let's do it in general. So I have 4 dots here. So let's look at x squared plus 6x plus 9. Okay, now this one, again, you might already have in mind like which one you're going to do. I don't know this yet, so what I'm going to do is look at this just a little bit more closely. Okay, x squared is, well, I can express that as really x and then all that squared. 9 is really plus and then 3 squared. And then 6, well, we need a 2 in there, and to get to 6 I need a 3. And then to get to x, I need an x. Okay, so it does happen that this happens to match that perfect square identity. So then we can say that this whole thing would factor as x plus 3 times x plus 3, or put more simply, x plus 3 all squared. Okay, so be careful of this. And also remember, this does not equal, okay, do not distribute exponents over addition. Okay, it will haunt you in your dreams, I promise, if you say that. Okay, I digress. Next one, 25x squared minus 9. So again, you might see this, others of you might not. What I'm going to say is, well, when I look at this, I'm looking for squares, right? Things that square to give to this, or get to this. So I know 5 would square to 25, and then x would square to x squared. Okay, and then this is going to be 9. Let's see, 9 is 3 squared, yeah. So then if I do this is a difference of squares, right? So that is going to factor as 5x minus 3, 5x plus 3. Okay, and that's all that there is to that one. Okay, these next two, we've seen these before, and I'll just, so like this one, I believe we ended up getting like 2x plus 5, and then x squared minus 9. Okay, so I'm just going to jot these down, and then this other one, we ended up getting 3x to the negative 2/3, and then 1 minus 2x, minus 2x. Plus x squared. Okay, so now I want you to try to finish the factorization of each of these. So certainly there's going to be a 2x plus 5 in this first one, and then there's going to be something else. And in this last one, there's the 3x to the minus 2/3 is going to be hanging out in front, and then we're going to have something else. So take a minute, pause the video, and answer these quiz questions. Okay, and if you didn't get the quiz questions right, again, no big deal. I'm just checking for completion. And so what this ends up factoring as is x minus 3 times x plus 3, because there is a difference of squares. Similarly here, this is going to be 1 minus x, or it really doesn't matter if you do x minus 1, because you square it all. It's a perfect square identity. Alright, so special factor forms take a lot of practice seeing, and so I would say have these identities handy, refer to them often, and get some practice going from right to left in each one of these, because that will help you establish that pattern in your brain, so that when you see the a squared minus b squared, then you're able to go from left to right now with this identity.